We appreciate you for being here with us at our maiden edition of this webinar. And I do hope your coming here would be worthwhile, and whatever we are able to discuss today would be very applicable and beneficial to each and everyone on this platform today. Okay, so thank you once again, and welcome to the Innovations in AI. I'm very much humbled to be the speaker for today. And today our title, as you've all seen on the various banners circulating around, to be bridging the gap from AI research to rarity, mastering the architectures and safety protocols needed to display scalable agentic systems. Now, since we are in a really mixed environment here, and some of our colleagues here, we have different levels of expertise here. We are trying to make it very fundamental, and in the questions and answers, if you have any questions, you are allowed to share them on in the chat, and we can answer all your questions as well. Please feel free to ask more questions, since that will help us to know the kind of audience that we are engaging with currently. Okay, so as Albert mentioned, Albert already gave a very deep details about myself and what I do currently. I am currently I started as a software engineer, now into the AI domain as an architect. My very focus is in trying to move products from the research level to a more scalable applied systems. And I also spend some of my time as a hobby to mentor students and also professionals alike in the tech industry. And some of the things that we are able to achieve by doing so is getting really good products around the world and also sharing our work to the community to benefit from what we are doing. This is my LinkedIn profile. Can feel free to connect whenever you want to connect, and then you can say hi on LinkedIn. Okay, so our roadmap for today is trying to have an overview or a real bird's eye view into exactly what has been happening in the AI world from the inception of transformer architecture through to what is happening today currently in the industry with reasoning models, agentic systems, and then all these amazing features you've been seeing AI display currently. So we are going to start off with the architecture model, moving through to generative AI. Then we will talk about some of the enterprise level techniques, which is mostly retrieval augmented generation, and moving on to some of the downsides of these techniques that are in there. We would move on to agentic AI, MCP, which is the Model Context Protocol, and then as a level of fine-tuning and then post-training, we'll dive a little bit deep into how you can fine-tune your own models if some of these top-level techniques are not applicable for your company or your project. Okay, so this is a brief history of the LLMs, which came up as a means of, even though we have some other past models that has been there before the inception of Transformer, that is the RNNs, the LSTMs and all that, but I wanted us to start exactly from where thing started with Transformers, which was published by a team at Google, which we had. Before that, we had the Attention is All You Need paper by Google team, and then we came to the inception of Transformers. GPT came in as a generative AI, but it wasn't very popular. It hadn't achieved the mark that it achieved with ChatGPT in November 2022. So between 2017 and 2022, we were playing around with these encoder-decoder models, especially one of those models that was really popular was BERT, which I think really boosted most of the NLP industries and small companies who wanted to do language translation, summarization. And I'm sure there are a few companies in Ghana that started with BERT, and they really, really did some massive work on the BERT, Roberta, and all those technologies. Then the final boom came in when ChatGPT was announced by OpenAI, which actually changed the game, and it has been changing the game from 2022. But we started getting some open source models as well, which is Llama 3.1, and so on and so forth. Then I think we had the aha moment where DeepSeek R1 came in with the reasoning models and how to also train your own reasoning model. So basically from 2017 to 2025, this is a summary of what exactly has been going on in there, and then we will try to expand whilst we are moving forward. Okay, now from 2017, as I mentioned, we had Attention is All You Need paper, and then before that, we move on to the Transformer paper, but I had already discussed this, so I wanted to move on to the next slide and talk about the different types of models that we currently have in the LLM space. So first, we have the encoder type models. Now, if you look at the Transformer, we have the encoder part and then the decoder part. Researchers were able to make use of only the encoder and also only the decoder models. And we also had both combined where you would be able to have applicable use of that. So examples of only encoder models are like for text classification, semantic similarities. So if you are looking at BERT, Roberta, they are models that could really, really do well in text classification and then other things. Now we have the decoder models, which most of them are trending right now, which is where we have the generative AI, especially where we are doing text generation, completion, instruction following, and then reasoning as well. Then when we bring both together, you would be able to, you have the sequence to sequence models where you can have language translation. Of course, if you are translating from P to English, you need this encoder-decoder type of models. Okay, now we move on to the LLM space where we say, okay, so what exactly is generative AI and large language models? Now, these models are just what I explained. They are more like the decoder models which has actually been trained on a really huge amount of data from the internet to religious books to published papers, just to make these models understand the world in the internet perspective. So if you look at it in the mathematical view, they are just give it more data and then it will be able to learn statistical patterns to generate some output for you. So the whole idea was to have it generate. So now the applicability here is we are able to use LLMs to do text generation. Example is ChatGPT. We can also use it for image synthesis and creating arts and videos. One really cool feature or one really cool application that LLM is thriving currently is code assistance, where you have a lot of applications like Codex, cloud code, really doing amazing in coding and all that. Another fascinating area is also multimodal AI, currently an AI would be able to take an image, process it, and then give you an understanding of those image, whether it be in graph or whatever application that you have. Reverse or conversely, AI can now also generate images and videos, which is very amazing. Okay, so how does generative AI actually work? So this is like the most simplest understanding or the most simplest idea I could come up with how Gen AI works at the high level. So what you need first is you need a training data. And then how do you get that? You have your whole data pipeline, you need to get data annotators, data labelers, and everyone involved into data to give you very good data. So that would be your data collection stage. Then you move on to your model training, where you would require a really high GPUs and what have you to train your model. Here you would require machine learning engineers, AI engineers, MLOps to be able to build this for you. So that after here, you get what we call the foundation model. Now, this foundation model are sometimes called like the instruction chain model. So these models are from the foundation model, you can do the instruction fine tuning, right? So after you get your foundation model, that is when you would decide to either fine-tune the model again or use other techniques like tool calling, retrieval augmented generation to actually build your system that you are interested in. The next one is what most of us are really interested in is the prompt, which is the prompt engineering. With AI, you have to be able to you need to be able to prompt it like ChatGPT, and then it will give you some generated output. As a newbie or as a new person starting with generative AI, what exactly should you look or what exactly should you want to start first is your prompt engineering techniques. This specific technique was overrated in the beginning and later it's underrated. A lot of people don't pay attention to how important prompt engineering can really optimize your workflow, because currently they feel like, oh, you give AI just a redundant information, it would be able to make sense of what you are doing. But if you are really building something robust, like if you are an example is if you are in the healthcare industry or you are in the finance industry, and you don't apply the right prompt engineering techniques, you might end up diffing the AI to give you like unnecessary tokens, which you might not need. And then you will keep adding architectures to your system, which might not be needed. So instead of saying, okay, let me work on prompt engineering, okay, let me just add a vector DB, let me do this, let me do that, which might not be the ideal case for your specific scenario. So it is very important to know the specific prompt engineering or have the skill to prompt the AI. And one amazing thing is, even though we have a lot of LLMs there, if you've tried them well, you'd realize sometimes the prompt that works for LLM A might not be working, giving you the similar output with the prompt that works with maybe Gemini or GPT or probably Llama or Quinn models. So we have various techniques in prompt engineering. The first one that we are all currently enjoying is the zero-shot prompting. This zero-shot prompting is where you just tell LLM to give you what you want now. So you say, okay, classify this patient as urgent or not urgent, right? And it will just give you the answer. That is just zero shot. You just tell it what you do. Now, few shot is more of training a kid. So when you are a teacher, you teach a kid, you give them a few examples, and then you give them exercises. So few shot prompting is when you give a few samples or a few examples and the answers to the LLM, and the LLM would be able to give you a final answer if you ask a question without providing the answer. So an example is, okay, classify as urgent or not urgent, then give it examples. I have a mild headache since morning, not urgent. So this really is very important because you are able to communicate your thought process itself to the LLM, right? So if you have, sometimes you can trick the LLM to give you what you want by giving it some examples, right? So let's say you have your own series of numbers and you don't want to follow the right numeral numbers, like 1 + 1 is 2, 2 + 3 is 4. You want to train the LLM to always give you probably +1 of the answer. Then you can train the LLM. Okay, if I say 1 + 1, I mean 3. If I say 2 + 2, I mean 5. Then the next time you ask a question, the LLM would have to give you, let's say 3 + 3, it has to give you 7. This is how some people feel that the LLM gave me a wrong answer, but LLMs are really biased, and they actually they prioritize your current ask or your current task over their pre-trained weights. So that is why sometimes you are able to pull the LLM to do some of these things, but there are some techniques that are currently coming up that would make an LLM be able to even correct you, the user, if there are some fundamental information that a user is not able to get right. Another amazing technique that really spun out a lot of ideas around even post-training is the chain of thought. This is where you actually want the LLM to think strategically, right? You want it to think like a human or how a human will break things down, right? So few shot is more like I tell you what I want you to give me. I've given you examples, give me answer. Chain of thought is like, okay, this is how I want you to decide, right? And all these things are just generating tokens. And according to research, sometimes when the LLM is able to generate more tokens, then it will be able to give you a very good response. So you are a healthcare triage assistant, think step by step, pick the main symptom out, decide urgent or not urgent, and then give one reason for that. This, you tell the LLM how it has to process the input or the input that you gave it or the prompt that you gave it. Now we have some other advanced techniques in prompt engineering that a lot of people are actually exploring. Currently, we have meta prompting. We have you creating an LLM or making an LLM itself as a prompt engineer and then verifying your prompt before you pass it into another LLM. But just as I mentioned, all these things, the deciding factor is on whether you want to pay more or just using an LLM to generate more tokens or getting good at prompt engineering. Okay, so now why does prompt engineering skills matter, right? Just as I mentioned, the same AI model can produce mediocre or exceptional results depending on how you instruct it, which means that I know some companies who are really good have very great prompt engineers. So prompt engineer itself is a skill that is currently needed in the industry where you all your job you have to do is craft very, very good prompt. An example, let's say if you have a medical doctor to prompt ChatGPT about a health situation, the results might be better than a random person who does not know specific things about health, healthcare. If you that is mostly the scenario, because you would know exactly what to say in the domain to make the LLM give you what you want. So whenever you want to study the act of prompt engineering, you need to spend more time into most of these techniques. And sometimes you can also let the AI itself train you or teach you how to prompt it. Most of the LLM providers also give out documentations and how to prompt their models to get the best out of this. And then good prompt could also reduce unnecessary iterations, as I mentioned earlier, and also become more cost efficient. So now we have the 4 elements of a great prompt. You give it the role. So mostly, you give it the role. So let's say you are that, and then the context. This is where you have to provide it a lot of detailed information, and then the task that you want it to do. Sometimes you would see some framework break this down. The context itself could be like the role, and the context could be what we call the system prompt, and then the task would be your final prompt that you want to give the model. Then you provide it with a format. Maybe make sure you give me 3 sentences or 204 words, whatever you want to give the prompt. Now, after prompt engineering, one of the downsides of prompt engineering was that if especially in the industry setting, if I want to do, I have my company with huge data, and then I'm not able to pass the entire data into the model every time I want to ask a question about it. Now, this brings in some few problems because LLMs are also bound by their context window, and then the number of input and output tokens that they can produce at each response or request response time. So which means that if you have million tokens of documents, you might not be able to pass them every time to the LLM to produce response for you. The issue is, one, you will not, it's not going to work. And then the second one is you might not even get a very good response from the LLM. So researchers and industry professionals came up with the retrieval augmented generation, which is RAG, where you teach the AI about your business or about yourself. I believe this specific RAG is one of the most important techniques that actually made LLM useful in the industry settings. Because over here, you have the liberty, or you have the opportunity to work around your own document, know what the LLM sees, sieve it across, even have a way of ingesting your document, but making sure that it has some kind of odds or like ODZ on it. So everybody has access to your vector database, but depending on the kind of roles and responsibilities that you have in the company will determine the type of document that you would be able to query in the industry or in the company. Okay, now let's see the problems that LLM solves, as I mentioned. So out of the box, as I mentioned, LLMs do not know about your product, your client, your processes, your proprietary data, and you don't want to sometimes also give everything to the LLM to actually give you results. An example is a customer service AI needs information about your return policy, your pricing, and your product to be able to assist clients. And all this cannot fit into the LLM at the same time. So you introduce what RAG come in here to solve. So RAG delivers accuracy. Responses are grounded in retrieved information. As you can see, the moment this LLM started, sometimes you ask the LLM about an issue in Ghana. We used to play around some issues in Ghana. You ask an LLM about, let's say, GPT, what do you know about the Seshi people of Ghana? And you get some kind of results that you are not happy about. You ask about, let's say, what do you know about DISA? It might not be able to give you much information. But when we inject DISA, or when we are able to keep DISA in a vector database with some other processes that I would talk about very soon, you are able to get information. And one technique that we were also working on was that whenever LLM gives you information, we try to make sure we target with the references, right? So with the references, we were able to know that, okay, this is where the LLM is taking the information from, and I can directly go in there, read about it, and then get some answers for real. Now, another thing was data privacy. So if you have your own data and then your own architecture, it helps you to make sure that data doesn't leak to the wrong person. And let's say we have DISA here and we want to ingest all our data. Not everybody has the right to get every information in DISA. So we make sure that if you are a mentor, this is the information that you have. All we have to do is to build an authorization pipeline into the RAG system. So if you're a mentor, you query, you would get to know what you have access to. If you are a student, you get to know what you have access to. If you're a research fellow, you'll be able to get access to. Now, the next thing is update your knowledge. Now, since LLMs, you need a lot of resources like GPUs, people, machine learning engineers to fine-tune LLMs. With RAG, all you have to do is just update your knowledge base, which should take you less than a day if your company size is small, or very few weeks if you have a really large company size. And even with a very robust data pipeline, everything should be automated at this case. So every week, you would be able to update your vector, or we'll be able to update your knowledge base. Okay, so now we move on to, so this is like the basic pipeline of RAG. I'll try to keep it high level so that we will understand what a retrieval augmented generation pipeline is. Then after that, I can mention some advanced techniques that are also out there. So you have your document here. Now the first thing, and this is one of the things that a lot of AI engineers overlook, is your parser or your scraper. So this part, if it's a website, you just need a scraper. You scrape your website, try to split it. Now, remember that since I mentioned LLM has context window length that you have to pass in, it means that you cannot pass the full document. So you have to create your document into chunks. You have to split your document into chunks. And this is just simple Python functions. Just use tokenizers to calculate the number of tokens per chunk. And then if it is up to the chunk that you set, it will then move it to the embedder. So let's say if you're having about 1,000 tokens of document, and then your tokenizer or your embedder is able to take like 512 by 512, then you can just section your chunks to be all document within 512. Now, there are some issues here that sometimes there is some information that is, let's say, if you have a very long document, some information might be lost because, let's say, your name is Leonard Mensah Boante. The Leonard Mensah goes into the first chunk. Boante comes into the second chunk. Now it becomes an issue because there is no relationship between that two. And if your LLM is supposed to retrieve your document, it becomes an issue. It finds your name, but it might find Boante, it might find Leonard Mensah, and then leave the rest. So there are some techniques that's like metadata tagging and some other overlaps that we deploy at the chunking area to be able to get to the embedder. Now, one other strategy is we have is you have to do like large chunks, and those large chunks, you also divide that into smaller chunks. So it's one of the strategies that you can do to ensure that you have a really good chunking strategy before you embed your document. Then moving on to the embedder. Now, when you talk about RAG, you realize that even the generation part comes later. A lot of work is done at the top, which is the indexing pipeline. So as I mentioned, even in the indexing pipeline, you actually need about two models. You need your tokenizer to be able to tokenize your documents into tokens before you can now embed them. Now, to embed them, you need an embedding model to help you embed or convert your chunks or your raw document into vectors before you can store them into the vector database. So most of the time, if you are building a RAG system, I would say like 60 to 70% of your work would be done in the indexing pipeline, because one, you are subjected to a lot of experimentations. You have to look at the best splitter or parser. There are a lot out there that a lot of providers are providing. You can talk about unstructured and other companies like Llama Index and LangChain providing some of these splitters. Then you have your embedding models. Embedding models, we have Google providing some, OpenAI, and our other companies also providing embedding models. We have multimodal embedding models where it can help you embed your images as well. Now, the final piece is going to be your vector database. Now, I'm not going to go deeper into vector database, but vector database is basically like an SQL database, but it stores vectors. So here, your LLM, the moment you think about LLMs, you know we are no more dealing with there and go and come. We're actually dealing with real numbers, which is like the embedder converts your model or your document into vectors. And all these vectors, because we need some kind of similarity index, we need a vector database to store those vectors as into that vector data store. Now here we have, this is one of the areas that I would say the industry also boomed. So companies like Pinecone, Quadrant, and Chroma also provide very, very good vector databases that you can use to store your vectors in your indexing pipeline. If you're also a fan of Postgre has an extension, which is a vector DB that you can just hook it directly to your company data, and then you would just have a vector data store to move around with it. Now, if you look at the generating pipeline, the generating pipeline is also like the reverse, but you need an LLM at the end. So here I come in, I already have my company have indexed some policies and information. What I'll do is I'll come in and then ask my question, and my question also has to be converted because we are going, even though LLM could understand the question directly, but the vector DB needs some kind of the vectors to be able to compare those vectors to what is stored inside the vector database. So the embedder does the same conversion, and then it's moved into the vector database. Now, inside the vector database, this is where the similarity index come in. So my query moves into the vector database, and then we have the cosine similarity and a lot of similarity index come up. Google has their own way of measuring some of these similarities to know what exactly is closer to the query that I am actually asking. If it is in my, if it is in the vector store, I get the retrieved chunks. So sometimes you could get some vector database could give you like 100 chunks, right? Based on how many contexts that your LLM can take. So you can get 100 chunks from the vector data store. And those vector data store, those chunks would be passed in as context plus your query into the LLM. So this is the only stage that the LLM even is coming to play here. So LLM just takes in the chunks as a context. LLM shouldn't know about something like there's a vector database involved or whatever. What the LLM needs is, this is my query. This is what I have. Give me the answer. So at this stage, it's just prompt and response. And then you are able to get an answer from the LLM. Now, there are some other important advanced techniques in RAG that has been happening. Number one would be query rewriting. So sometimes what happens is that if I ask a question that might be an inverse of what is in the vector database. And an example is that if my company has ingested a lot of data, and then I type in a question, even though my name is already in the number of how do you call it, in the vector store, but when I ask the RAG, or if I ask the system that what is my name has nothing to do with Leonard in the system, because if LLM goes in and brings all names, definitely LLM is not going to know my name unless it has some memory or context about me already, which is outside the RAG. This is why you can use what we call query rewriting, where an LLM would be able to process your query based on its own understanding, give you feedback, let you rewrite it, and then it will go back and then push that query into the RAG pipeline to get those specific vectors for you. So one way is an LLM could even generate like different versions of your query. Right? So let's say you ask a simple question, LLM could use its own understanding to generate like 5 different versions of your query, push all those into the vector DB pipeline, and then be able to get some accurate responses for you. And that is what we call the multi-query retriever. Now, the next thing is hybrid search, which is very, 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 very important. So one thing is vector DBs sometimes cannot solve all your problems. Sometimes you realize that even your data you want to index a simple SQL data, which is very, very structured. And vector databases are not that good with structured data, which means that you need some kind of hybrid system where you have 3 databases or 2. One is a structured database, the other one is a vector DB. So what you do is that your query, LLMs could also process your query into an SQL form and then query the SQL database, query the vector DB, then give you your results back to the LLM. LLM would be able to give you some really nice and cool answers. Another amazing thing that was also explored was the graph reconstruction, where Neo4j and other graph databases come in, where you would be able to actually process. So in the indexing pipeline here, you can even tag your documents. And if you have interface with RAG before, you have your notes where all this processing could happen before you move the data into the vector DB. So when you have your query, the LLM itself would be able to, not the LLM, that you could be able to get some information, relevant information. So if you are looking for the senior AI architect, LLM will be able to get you the information of architect, even with just the graph, before you would use those information of the architect to query the vector DB to give you the full information of this architect. So when you have graphs inside your RAG pipeline, it's super helpful, especially when you are dealing. A practical example is when you are in the healthcare space, where let's say you want to build a RAG system where you can connect diseases and then researchers and then countries and what they are doing. One good scenario would be, let's say you are a cancer researcher, and then you want to know what is the current trend and what is each cancer researcher doing right now. And you are able to have a RAG system like this. If you type in, okay, I want to know what is happening in Africa about, let's say, skin cancer diseases. Definitely, it would be able to use that to connect all the researchers in Africa that are doing something about skin cancer. Now, getting that first-hand information alone gives you a huge context that you'll be able to pass into your RAG pipeline, because you'll be able to know that, oh, okay, there is Albert who's just published some work, because Albert's publication is a node connecting to his name, which is also a node connecting to his credibility and then his works. So this information alone is a huge context for you to pass into the LLM. So you go into the LLM and say, okay, now prove everything that Albert is working on for me, and I can move on with my life. So this is why Graph was very, very, very instrumental in building very robust RAG applications. Now, the next technique that we also had was using some models as re-rankers. So what we do is that when you are able to retrieve, so in the retrieval pipeline, sometimes you can retrieve about 100 documents, but you want to have a way to re-rank all these documents to be able to get only the top 10, because this is, you don't want to push all the 100 documents into your LLM. So there are some models that you can use to actually re-rank all these, all your documents, and then cut off the first 10 or the first 15 before you push them into your LLM to generate the answer for you. Okay, so with all the discussions that I'm having now, there are a few failure points, as I mentioned, in RAG, that whenever you are building a RAG system, you need to be aware of. The first one is your data ingestion scalability, your chunker, your chunks, things that you have to be aware of. So if you look at this diagram, if you look at missing content, it means that you have to clean your data with better prompting, and then you would be able to get the right content in the retriever pipeline. Now, when you are talking about the missed top ranks is like when you have a lot of data, and even though your retriever has done a great job to give you the right document, but because it retrieved about 100 chunks, and all these 100 chunks cannot go into your LLM, you end up taking only the first 20. But the most important information might be in the 98th chunk, which is very crucial if you are especially in the finance sector or you are in the law sector, because sometimes you are a lawyer or you are an analyst or a researcher. You want to be able to fish out some policy, or you want to be able to fish out a law, and you trust, you've built a RAG pipeline, like, oh, okay, this RAG pipeline, 99% failure proof, and you are not able to have a re-ranker, even though your retriever is giving you all the information, but your system is cutting them off, and the most important information or the most important clause might be in the 98 chunk, and then you end up losing a lot of money to your company. So this is why you have to do a lot of iterations, right? Most of these processes, I've seen a lot of people just deploy when it works without really testing and evaluating. And at the end of the day, it will come back to bite you. So you do your hyperparameter tuning, you find some of these good re-ranking models and try to apply these techniques in your RAG pipeline. Now, in your rank chunk, sometimes you have things that are not in the context. So you realize that even with manual evaluation, I have indexed this document, but the document in my retrieval pipeline, that specific document is not in there. With all the prompts that I have tried, this document is still not getting retrieved. So this is when you look into the embedding model that you are using, or you tweak your retrieval strategies, try to add more strategies to be able to get the right retriever. Now, the next one would be your data not extracted. So even though you can give your model the right information, it might still not use it to generate the response. So this is where you have to clean, compress the prompt, or kind of deploy about 2 or 3 models, take this context, summarize it, give the understanding to this, take this context, summarize it. Then the final LLM would aggregate all the responses and then provide a very good response. Another one is wrong format. So this is when you have to provide specific format. So here we are saying you do better prompting, output parsing, Pydantic programs, and OpenAI. So we have some structured output strategies out there that you can just use Python, Pydantic to force the LLM or restrict the LLM to output specific format. Now, this is very important, especially if you have like multi-systems, because you might be retrieving an information into a specific JSON to pass that information into another system. So over here, getting the LLM to output the right format is very crucial. So it's better for you to use some of these Pydantic models or OpenAI JSON strategy to allow the LLM to output the right JSON format for you. Now, the next failure mode would be the incorrect specificity, which you can correct with just advanced retrieval strategies. Then we have the 7 to be incomplete. Now, incomplete here means that it's more like the same, not extracted, but here your document or the information that you had is not really directly corresponding to what your model needs to generate. So what you do is query transformations, and then also with respect to things like your data ingestion scalability, what you need to do is a lot of parallelizing ingestion pipeline. So for you to build a RAG system, especially in the enterprise setting, you need to also be a little bit focused on data engineering, right? Because if you don't know how to build data pipelines and you decide to just do naive RAG or those kind of things, you would end up burning a lot of tokens and then losing a lot of money in production without yielding a very massive result that you would need as a company. Now, the 9th one is structured data and then complex PDF. So this is really important because sometimes when you are working with a company where they have a lot of documents, but the problem is some of these documents are just tabular data, right? Like just tabular data in there. And whenever you pass them directly, your parsers are going to convert this tabular data into just text, chunk them, and then by the time it gets to the embedder doesn't know anything about the tables. It has no idea that this is a table. It has no idea that this is an image. All it has to do is know, okay, I have a text, I chunk it, I get it there. But let's say I have let's say an Excel sheet. I have exported it as a PDF, and then pass that into a chunker. The parser just does it and give me the text. But I have a full calculation of my expenses, and the total is at the bottom with about different years. I query the LLM to give me the total of 2024. It's not going to know what it is. It's not going to really know what it is because it doesn't understand it. So when you are dealing with structured data, some of the things that you have to do is like chain of table pack and then mix self-consistency pack. Another thing is embedded table retrieval. One other thing that I've seen is people also directly just embed the table like images into the LLM with vision models so that the vision model directly understands that this is a table. Now, the next one would be a fallback model. And then we have LLM security, where you can, for security, depends on the level of security that you want to go. If you don't want your model to go into an external model provider, that means you have to fine-tune your own open source model. Probably security might be you don't want other systems or other external systems to ingest your data. Then it would depend on the level of expertise that your engineers have to be able to build such data pipelines for you. Yeah. So this is like the summary or a short version of me explaining RAG and what it's about, but there is a lot that you can actually do with RAG. I know it's not really getting the attention currently, but I think this is one of the most proven techniques that is giving companies ROI currently, even though we have other strategies which causes issues in deployment. But with RAG, just as I mentioned, it was adopted, and then most of these fail proofs can be resolved earlier in your company. Okay, now we move on to another amazing thing, which is tool calling and function calling. This directly relates to LLMs because if we have RAG, the problem is that every day I have to script a website. So let's say I want to track websites like WHO or the GDPR in order to know their updates, to know what they are doing. I want to know the new records about the Ghana Health Service, to be able to provide people information about that. That means every time I need to build schedulers, I need to build triggers to every day script the information and then ingest it before my users can be able to use this information, which is very, 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 very redundant. And sometimes you have to do a whole lot of cleanups, and yeah, it takes a lot of that time. So the idea is that if I have a tool that I could just hook it to my LLM, and whenever the user asks, what is the current happening in WHO? We just have a web search to search the WHO website, picks what is there, and then give the results. That is a very simple way to do than building a whole RAG pipeline for such a simple task. So what is tool calling and then function calling? This is just giving the LLM the ability to be able to use or query APIs, execute code, and interact with the real world, right? So LLMs now would be able to do what you would do. So instead of building a whole API, fetch the information before you give the information to the LLM, here you are more or less like, hey, this is the API or this is the route. These are the arguments. Go in there, fetch the information, and use it yourself. Another amazing thing is LLM has to decide even if they need the two, even though you have given them the two. So this was another game changer in the industry, especially with the aspect of an LLM being able to execute code. Okay, so we have our pipeline of the tool calling. Now remember that tool calling, RAG, and all these things we are discussing inside one whole big ecosystem. So you can have a system, tool calling capabilities, RAG capabilities, agentic capabilities, and so on and so forth. So I have my prompts, pass it into the application. Application is full of prompts, LLMs, and functions. LLM takes the prompts, decide the tool that it has to call, and then call that to get the response, pass it back to the LLM, and then the LLM give me the response. So I believe most of us have been engaging with this where you want a quick information about yourself. You go in there and then you are, now everybody is like a hacker because now you meet someone, you mention your name to them. All they have to do is go to online, type in your name. Of course, unless you are not popular, type in your name, get the first link, give it to LLM, say, okay, LLM, go and search about this person and then give me his profile. LLM just does it. And in 1 minute, somebody has already built a profile about you, which is very, very, very amazing. And this can really help, especially if you are a salesperson or a marketing person. And then you are going off into a meeting, right? You are a researcher, you're a professor, you're going off into a meeting. You don't really know who you are going to meet. This strategy, so it was like, I saw with an example, a film my sister forced us to watch, where before you go into a meeting, your secretary has to know everybody that you are going to meet in the meeting. So before you shake anybody's hands, your secretary would whisper into your ears who the person is, who they are working with, what they just did currently, what they care about. So you meet the person, you smile, you talk to them like you know them, but meanwhile, you have the secretary doing the groundwork for you. So this is very, very, very helpful, especially if you're holding ChatGPT, meet someone, quickly type in, okay, what is this company about? You go for a conference and then a speaker is speaking. You want to really have a chat with them at the end of the meeting. So you quickly Google them, give them to ChatGPT. ChatGPT give you some information about them. And then you go there. I'm not saying you should copy it, but you go there and talk to them like you've been following their research for over a decade now. They feel happy about you. You exchange connections, and then that is how things move on from there. Okay, so what are some of the real use scenarios of tool calling? Now, customer support bots that look up order status. I think there are some companies that are doing this right now in Ghana, but not that effective. So you can just directly chat with the company bot. It will retrieve all your information, talk about what you need, and then before it would escalate your information to the maybe the main assistant or the human in the loop assistant. Now, the other thing is coding assistant that run and test code. An example is Codex, Gemini, and then Cloud Code, which is doing amazing. So all these code assistants now can execute code, right? If you look at Cloud Code or Codex, they have their own Python interpreters where they could just execute code, understand it, call these executors or interpreters, understand the code, know what is wrong with it, correct it before they even come back to improve the code base for you, which is very amazing. So you don't, in the early stages of ChatGPT, you get a code from ChatGPT, you have to execute it yourself, and then you have to execute it yourself before you can then copy or type it back into your IDE or something. But now if you are using Cloud Code or even you're using Cursor IDE or Windsurf, all you have to do is just write some tests. And if you're really good at test-driven development, you use LLM to write your test. Just go to the LLM, test it, ask it to write the code and make sure it passes the test. And that is it. At the end, you have a full code running for you, which is very, 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 very impressive. Another one is Deep Agent that search and synthesize information. So if you look at Perplexity, deep research from OpenAI, and then also the research agent from Google, they are able to do research for you. So just give them your topics. They can use the web search tool and all the tools they have, do research for longer time for you, then synthesize the information, give you a full document of what you actually need. Now you have other personal assistants that manage calendars and emails. This is very simple. You can just give the LLM access to your emails and calendars. And sometimes you have some a pool of prompts or a pool of templates that the LLM could actually go in there based on the email that came in. LLM just goes in there, fetches your own style, and then give you, okay, this person sent this information. This is the response. Do you agree? You click agree, and then it just uses the tool to send the information back to the response back to the LLM. And this can actually save you a lot of time, right? And it's also sometimes better than the whole generation thing, because if you're able to do this and automate it yourself, you know the kind of people that send you an email. So you have a template. LLM can go in there, check the template, then craft an email based on that template. And all that you have to do is to click and then move on. One other amazing thing is also financial tools that pull live market data from places like FinHub, and then all these market data. If you have an LLM, you don't need to be scrolling the internet for information anymore. Just hook it to some of these tools, trigger it every morning, and then ask it to fetch the new information, summarize it into some cards, or gamify it into a way that only you would like to read it, probably send it to you, and then you are off you go. If you want to go more advanced, you could even create like bots with a Telegram bot, try to use some other technologies to even let it send some WhatsApp messages to you and all that, which is very, very, very amazing. Now we move on to the big one that took wave ending 2024, 2025, and now it's really making waves. Now, agentic AI, I would say, is like a smarter way of all that we have discussed later. So if you remember, we mentioned chain of thought, where you give the LLM specific steps to go through in order to execute a specific prompt. Now with chain of thought, the agentic AI, what happened was that there was this paper called the React, where an LLM would just act and then plan and execute, right? So you plan, you observe, and then you execute. So by this is where we started with using the LLM smartly to act as agent. And then one of the frameworks that started doing this was, I think, LangChain, where they had this agentic executioner. So you have just the LLM in there, provide it with tools, and then prompts, just ask it to do the act, the observe, execute, and then the whole iteration begins. So this came in, and most of these frameworks started doing this. So we had frameworks like Crew AI, we had Microsoft bringing in Semantic, and all these auto agents that came in to give us some of these amazing ways to use LLMs to actually perform some of this task. Now, another thing that was also very important was how we were able to have a separate memory for these LLMs. And then the agent would be able to use memory to actually update their decisions and then come back to the LLM, had this whole feedback loop happening in there. Now, the next one was like, oh, okay, we are giving this LLM everything, but sometimes a human would want to also be involved, right? So I am a customer support. A user has called in, they are negotiating for, let's say, reduction or discount or something like that. LLM has been able to do that, but the challenge is that at the end, we need a human to confirm or deny and then give feedback so the industry introduced what we call the human in the loop to help the humans to be able to be involved. And sometimes human in the loop don't just terminate. In the human in the loop, you'll be able to give the LLM an answer. It will go back to its decision, update the decision, come back to you in that one. So you work with the LLM, but it's no more like prompt and response. LLM come back with, okay, I'm done with this. What else should I do? A really simple one would be when you are using the Google Deep Research, where you ask it to do a research, it will come back with a list of questions. Then you have to give it some response, even though that is just a single loop. But we have LLMs where you have probably multiple loops. An example, if you are in Ghana, and then your company deals with processing a lot of receipts and invoices, right? You may want to make sure that some of these invoices and receipts are probably standard or they are accurate before you process them. So if you're an accountant or somebody like that, you want to make sure that before you process or you push every invoice to pay, you want to check their tax details, making sure operations, everything that is within the invoice has already been delivered. So you need to contact a lot of systems that I think most financial or in the account section, they use like the SAP to be able to retrieve all this information, compare them into what is on the invoice before you would be able to push them into pay. So sometimes LLM is able to flag a lot of inconsistencies in these invoices, and then you, the human, would have to probably confirm, deny, or accept these inconsistencies before the LLM would go in to do its job. Okay. Now we have different type of agents. This one, just going to give a brief overview of this one. So we have just single agent, and when we say single agent, just an LLM with multiple tools. So this is like where the React started or the agent executioner started. So I have a single LLM, I give it a list of tools, and then I give it a prompt. With the prompt, LLM will have to decide the tool that it needs, and then execute that, give me a resource, and then I proceed from there. Now we move on to the multi-LLMs or the multi-agent architectures where we have the network. So here you have 4 LLMs in here. Now all these 4 LLMs are practically independent, but they fetch information from each other. This one, you give the prompt, this LLM will ask this, what it has, this would ask this will ask this, and then they would all come together, bring their resource, and you get your response. The next one is the supervisor. So the supervisor is where you use one LLM as an orchestrator, and then it will give the task to all the other LLMs. So supervisor knows that, okay, this LLM is responsible of checking policies. This LLM is responsible of picking orders. This LLM is responsible for executing maybe a trade or something like that. So if I have a query, the supervisor will decide which of the LLMs that it will call. So before it does anything, it will first call, let's say, LLM is supposed to execute a trade, what it will do is that first it takes the query, ask the policy agent, okay, is this meeting our policies? Yes. Go back to the LLM that is able to do the whole calculations to check the whole risk and rewards and everything. Get the rewards and then bring it. After it is done talking to these two guys, it will directly go to the execution LLM to execute a trade and then give it back the response. So if you are from the software engineering side, I mostly picture this LLM as just API calls, and each and every one has its own specific, they have their own specific functions that they have to perform, and they would always have to come back. That is one of the things about these architectures. The moment you give an LLM something, it would always have to come back. That is why you need the supervisor, because when you ask this, you would be getting the results here. There's nothing like the results going here, another results passing here, another results passing here. That would mean you would need different systems or different kind of strategies to take those results. So if you have the orchestrator, anytime this goes in, it comes back. Anytime this goes, it comes back, come back, and then you are over there. Now, this same strategy, you can use that to build a whole hierarchical or custom agentic system. What you have, I think I've seen a lot of people who can do over 50 to 60 LLMs inside a specific setting, doing a whole different things. Some processing languages, some doing different things. So this you can build a hierarchy. This is where if you are a senior engineer or if you are an architect, it really helps you because you would need a lot of decisions here, even to group these LLMs into different graphs. Now, if you look at LangGraph came up with this idea where the hierarchical strategy, your entire LLM agent becomes a graph. And what you would do is that each hierarchy or each section would be a subgraph. So they will do their own thing there. They have their own supervisor. They have their own whatever they are doing, and then bring the results back to the top node or the top graph, and then in that order. So you would realize that the more you expand what you want the LLM to do, the more agents that you would need. So at some point, you would have to group your agent into specific areas. And then so you can have a group that are focused on RAG. So that group would be focusing on your company data. Another group will be focusing on external information. And then another group would also be focusing on execution or anything else. Then they'll come together, then give you the information that you actually need. Okay. So yeah, so these are some of the frameworks that are there if you want to try building some agents. So we have semantic kernel, we have AutoGen, we have AutoGPT. LangGraph is very popular and advanced. And if you are more interested in the open source world, Hugging Face also provide this small agent. LangChain is also another platform by the LangGraph group, so you can explore some of these frameworks. Okay, so these are a few things that you have to pay attention to when you are dealing with building agents, because it could happen so fast. Is to look at prompt injection and tool misuse. Sometimes some of these tools, you have to make them deterministic because there are certain things that you don't want to allow the LLM to decide. So sometimes with your sub node or your sub graph, what you do is that you tell this LLM specifically to call this tool before it calls the other tools to prevent any tool misuse, so that the LLM doesn't have to always think about the tool that he has to use. You have to also look at the concerns of data privacy. Now, if it's just a single LLM and request response, that is okay. But sometimes you want to have a whole data privacy layer in your LLM where you are only using open source models, or probably like some rule-based or fuzzy system to make sure no data or no sensitive data leaks into the probably the advanced or the proprietary LLMs, especially if you have a system where you have to retrieve information about people, but you do not want to really provide that information into the proprietary model, means that you need a really good model to mask all this. You need a very good technique to mask all these names before they are passed into the LLM to prevent leaking data in this area. Now, another issue could be reliability and hallucinations. Still, LLMs or agents are subjected to hallucinations, right? So this is something that you can avoid with very good evaluation techniques. Now we have evaluation methods. You can look at Langfuse, Langsmith, where you would have different metrics that you can use in checking some of these things. Okay, so the next strategy that I'd like us to discuss is the model context protocol. Now, this came in to solve the whole tool calling issue. As I mentioned, sometimes you might have a system that you have to build a whole lot of tools, right? Imagine if you have an API, like a big API, let's say like PayPal or some of these big companies, and you want to build tools for them, for your company, because your company is actually using PayPal, or your company is using a payment system. You always have to build some kind of tool to connect to those company API, which sometimes is a lot of. If you are really integrating, you have about 50 external services, and each is providing 10 API calls. You need about 500 different tools to call these specific external systems into your workflow, which is a lot of work because there are other issues on how to build the right tools. So if you don't take care, you'll be burning a lot of tokens, and then some of your LLMs might not even call the right tools, and you have to have a whole layer of even orchestrating and managing tools. So this is where the USB-C ports for LLMs came in, where we would have a standard of providing these tools with additional benefit. So the whole idea is that if you are now interfacing with PayPal, you don't need to build tools for them. All they would have to do is to give you their MCP, and then your client would directly talk to their server and then get the tool that you need anytime that you are querying the model. So I would say majority of people overcomplicate the issue of model context protocol, but if you understand the context, or you understand the context of USB-C, you could just see that it's just a standard where it's just a standard to get information or to get tools from external systems without you having to go in there, understand their API structure, and then build it for them, or build it on your system. All you need is the MCP, plug it into their server, and then get your information. So it says that MCP provides actually a standardized way to connect AI to external system. I'm sure by with time, when we'll be having more of these sections and we'll be having deep dives where we'll go really deeper into the tech, into how all these things work. Now, why does MCP matter? We have it reduces development time and complexity when building or integrating with an AI application or agent. Just as I stated, that you don't have to be understanding their APIs or their tools. All you have to do is to get their server, plug it into your client, and then you are happy to go. It also provides access to an ecosystem of data sources, tools, and apps, which will enhance capabilities and also improve your end user experience. For end users, it's more capable application, right? So if you have an MCP, if you are using an MCP on any, if you are a great user of systems like Kesa or Windsurf, you can basically have your own MCP server, plug it in to, let's say, standardize your code base. And every time that it just generating some code for you, it references the standards and make sure that it can generate this code base according to your standard. So if you are a company, you can actually let your engineers build their own standard as an MCP server, and everybody host it, everybody that comes into the company. You don't need to really give engineers or onboarding engineers with a full document. You don't ask them to go and read. All they have to do is that during coding, this server, this MCP is always invoked, and then it would enforce some of this into your system. You could also add an MCP to your testing pipeline, to your whole actually pipeline to be able to help you, let's say, review pull requests and all the benefits that you get from MCP. Now, with the MCP architecture, for time's sake, I'm just going to give just a simple overview. This is how it looks like. We have the host, the client, the server, and then the external tool. Now, the host provides the client. So these two mostly, like if I'm on Cloud will provide the client to be able to interface with the server. And then this server, as I mentioned earlier on, is where the tools are. So you can have an MCP server for all these tools, and you don't have to worry about this as long as you have this host. So if you build your host, we have other clients that are local. So you can have local clients where they will directly interact with the server for you. So the company would provide this for you, and then you would just connect it to your system. So these are some of the key definitions. So the host is just the AI application that coordinates and manages one or more MCP clients like Claude, Kesa, and then VS Code, as I showed. And then the client is the company that maintains the connection. And mostly the client you would be trained, or you'd have a documentation of how to set this client up to be able to obtain the context from the server for the host to use. Then we have the MCP server, which is the program that provides the context to the client, and that is mostly provided by the MCP provider or the API provider or wherever your external system sits. Now, as I mentioned, MCP is more like the new API standards and everything. So we have two different layers, which is the data layer, which defines the JSON RPC protocol for the client-server communication, which includes the lifecycle management core primitives, such as the tools, the resources, the prompts, because ideally, what MCP is giving you are like multiple tools, multiple resources, prompt, and then notification. And then we have the transport layer, which defines the mechanisms and channels that enable data exchange between client and service, which include the transport specific connections, establishment, message framing, and also authorizations. Now, the last thing that I would want us to probably discuss is the reasoning models. Now, as you've seen that most of these LLMs are just like direct, you ask them and then they. So with the idea that if LLMs are able to reason or they are able to give out more tokens as a mathematician or as a computer scientist, this is like just more tokens. And this special token that came up, even though reasoning models came about when OpenAI introduced the reasoning model o1, by that time we did not know how the reasoning models were trained until DeepSeek came in with the aha moment where they revealed the secret into how you can train a model with just a single token, which we call the think token. So all you have to do, all they did, if you go into the paper, all they did was basically ask the LLM to think in a think token before they are able to provide the answers. And what has been realized is that these LLMs are very powerful, and then they are able to do more than the basic ones that do not have this thinking token in them. Okay, so how do you deploy this reasoning models? Like now, when you are fine-tuning these models, you have to be careful because sometimes they're thinking they can think for longer. So you have to actually cap them. Sometimes there are certain hyperparameters where you would be able to set the number of tokens that the LLM should be able to produce during their thinking. So you cap the tokens, you set time, retries, and also the number of true cores. Now we have measurement, how you can measure it. There are accuracy lift, pass K, escalation, the cost per task, and also latency. Okay, now after all these processes and then you still are not getting what you need from your AI, what you move on next is the post-training. So all that we've discussed so far is for the foundation models. You just use the foundation models. So what you actually do now is you attack the model directly. You would have to fine-tune the model to your company data. So here you would have to do your own data processing, everything that you need to fine-tune the model. So we have different strategies. We have the supervised fine-tuning. We have reinforcement learning with human feedback, and then some different techniques that are also coming into play. All right. So what is the supervised fine-tuning? It's basically like training the model on a data set of curated prompt responses to teach it how to answer questions properly. We also have reinforcement learning, where you use the human preference data to train a reward model that guides the AI to produce better, more aligned answers. Now, one other strategy is also to remove the reward model and use probably fuzzy approaches or strategies that are now popular, like the GRPO and then the DPO, to fine-tune your model. We also have the parameter efficient fine-tuning, where you need just a rank of the bigger model, fine-tune it, and then reintroduce it back into the model. So this strategy is what helps a lot of students and young researchers, to be able to fine-tune models without actually spending a lot on GPUs if they don't have access to it. Okay, so choosing the right approach with all this. So I listed mostly some of these 4 or 5 things that you start with. So with prompt engineering, that is where you start with. Then if you're not getting the wins that you need, you just start with, you move into RAG, then fine-tuning, and now you can move on to the RLHF, DPO or GRPO, and then you have the full pre-training model. So finally, this is the whole agentic stack, and then I'm sure the slide will be available. So if you are interested in any of the areas into building agentic system or getting the scope really well, you can experiment on some of these tools here. When you at the ground level is when you want to do your own fine-tuning and deployment. Evaluation techniques like deep eval and then RAGAS, great. With the LLMs, you can start from this. Then we have the frameworks. You can move on to the vector DBs I mentioned. And then we also have the embedding models here. Data extraction, you have Firecross, Scrappy. So this is where you want to Llama pass, where you want to do your own passes and what have you. We also have the memory and then the alignment where you can look at Arise, Langfuse, and then all the other systems. Okay, so finally, I'd like to talk about if you're a student or a new researcher, what are some careers that you can explore in the AI space currently? We have the prompt engineer that I mentioned. If you can be really good, not that at a high level, but if you are really good, and most of these prompt engineer could be someone who is already experienced in a specific domain and you want to switch into the AI space, what you could do is start here, learn how to craft very, very, very good prompt to get really good output. Then you can move on to the coding aspect where LLM and Gen AI engineer is needed. We have the AI engineers themselves. And then with maybe the next time I'll be able to explain more on how each of these different roles differ. But for now, these are some of the roles that you can target as a student who wants to get into the space. All right. Thank you very much for staying with me all this time to actually educate myself on the current trends and innovations in AI and